today we are going to discuss different types of equalizer, which is called adaptive equalizers as part of your advanced communication system. That means in wireless propagation channel, how this multipath effect can be adaptively negated using adaptive equalizers. Now, in my previous lecture, we have discussed on linear equalizers, types were zero forcing equalizer and MMSC equalizers. So we have discussed these two types, and these two linear equalizers had one limitation, that the constant multiplication factor or the weights were indicated as WK. So this is the constant multiplication factor which is used for multiplying it with the received signal YK. Yes. So by multiplying or by choosing this coefficient factors or weights, this is constant in terms of your linear equalizers, both zero forcing and MMSC equalizers. In both the scenarios, the multiplication factor, once it is decided, it is fixed. It is not changing by the changing nature of the channel. Okay. But in this case, adaptive equalizers are more advantageous. Why? Because they are having the constant factors of the equalizers. They are evolving, or they are adapting, or they are changing with respect to the change in the channel characteristics. Okay. So the channel characteristics is always changing. Why? Because environmental factors are changing. So channel is always evolving. Because the environment is changing, then there is movement of your transmitter and the receiver. There is movement of the objects between the transmitter and the receiver. So there are many factors which are involved to make the channel characteristics vary with respect to time. So when the channel characteristics, which is indicated by H of CF in terms of frequency domain, so when this is varying with respect to time, that means as time changes, this characteristics is changing with respect to time. So it is not constant. So because the channel characteristics is not constant, when a signal is propagating through this channel, the multipath effect or the multipath components would also vary with respect to the channel and with respect to time. So what is happening? Because the multipath effect is also varying with respect to time, these constant multiplication factor will no longer be applicable to overcome the effect of the channel. That means in order to overcome the effect means to overcome ISI. Okay. So what is ISI? ISI is intersymbol interference. So in order to overcome this intersymbol interference, we need to have an adaptive choice of multiplication factor. Adaptive choice means what? That as the channel is changing with respect to time, that means as this factor HCF is changing, the multiplication factor should also be changing. That means they should no longer be constant. So what is the major limitation of zero forcing and MMSC equalizer is that they assume that the channel characteristics is fixed. That means HCF is not changing with respect to time. And then they select the weighting factor and multiply it with the received signal sample and recover the signal. So what is the recovered signal? The recovered signal is called DK bar or DK cap. Okay. So this is the fundamental of your, so this is called DK cap. That is the output of the equalizer. This is the regenerated transmitted signal at the receiver side, output of the equalizer. Now, adaptive equalizers, they are using changing weighting constants based on the nature of the change in the channel, and they are evolving or they are adapting this constant factor and constantly changing this multiplication factor, multiplying it with the received signal and generating the output such that the error between the transmitted and the received signal can be as low as possible. So this is more advanced kind of equalizers in your syllabus. Okay. So let us have a brief introduction of what is adaptive equalizer, why adaptive equalizers are needed. So in wireless communication channel, the channel characteristics is always time varying. Time varying means it is changing with respect to time. Now, why is it changing with respect to time? It is changing with respect to time because of the most important factor, which is called the user motion. Motion means there is some movement. Movement means there is some velocity and it is covering some distance d and it is changing with respect to time. Clear? Now, user motion means what? User motion means either the transmitter is moving or the receiver is moving. So, motion can be the motion of the transmitter, motion can be the motion of the receiver, or motion can also be the motion of the obstacles in between the transmitter and the receiver. So what are these boxes? These boxes are nothing but the obstacles in the path of this radio wave or radio signal propagation. So these are obstacles whose size is much greater than the wavelength of the transmitted signal. So size is much greater than the wavelength of the transmitted signal means what? That they will cause some amount of reflection when the signal from the transmitter is hitting this object. It would cause multipath effect and this signal will be reflected and it will reach the receiver through multiple reflections. So it is having difference in both the amplitude because as it is experiencing multiple reflections, the amplitude of the signal will reduce or will change and the phase of the signal will also change with each reflection. Okay. So here motion means three factors. Motion means the movement of the transmitter. That means the transmitter can be an antenna which is mounted on a vehicle, moving vehicle. Or it can be the movement of the receiver. That means transmitter is fixed. Suppose the base station that is there, mobile tower. Here you have the antenna. So the base station is fixed, but the receiver is an antenna mounted on a vehicle or it is a mobile phone whose position is varying with respect to time. Okay. So this is the second scenario and the third scenario is if any obstacle which is in between this transmitter and receiver, if there is any obstacle means it can be any other vehicle, it can be any building, not building exactly, buildings are fixed. So it can be any mobile vehicle in between the transmitter and the receiver. So transmitter can be fixed, receiver can be fixed, and the vehicle and in between the obstacles can be moving. So this can be another car, a large object, or a truck. Okay, so a big large object whose size is much greater than the wavelength of the transmitted signal. If this object is moving with respect to time with a certain velocity v, then also you will experience the change in the channel characteristics. Okay. So now how this channel characteristics are changing, we need to study that. So based on the motion or the speed of the movement of the object, it can be either the transmitter, receiver or the obstacle, we experience something which is called Doppler shift. Doppler shift is nothing but it is the change in the frequency of the transmitted signal. Okay. Change in the frequency of the transmitted signal means what? Means that suppose I am transmitting a signal which is, so let us call this as Fs. So my transmitted signal has a frequency, let us assume this is 100 hertz. Okay, so this is just an example for you to understand what is called Doppler shift actually, and how frequency of the transmitted signal is changing when there is movement of either the transmitter, receiver, or the obstacle. Clear? So in our case, we will assume that the transmitter is fixed, but the receiver is moving. Okay, so we will assume that the receiver is moving. Now there can be two scenarios. Scenario one is when the receiver is moving towards the transmitter. Suppose the car is moving towards the mobile base station. Okay, then what is the Doppler shift experienced at the receiver side? So when this receiver is moving towards the transmitter, what is happening? The signals which are being transmitted here, they will hit different objects, they will experience multipath effect, and as this is shifting towards the transmitter, different multipath component will reach at different time period at the receiver side. Okay, now in this receiver side, when it is moving towards the transmitter, we experience that the frequency of the received signal, let us call this as case 1. So let us take this as FR1. What is FR1? FR1 is the frequency of the signal received at the receiver end in scenario when the receiver is moving towards the transmitter. Okay. Now the movement is having some velocity v. Clear? So we see that the frequency of the signal which is received at the receiver is high compared to the transmitted signal. High means what? Suppose I am getting here a frequency of 150 hertz. So what is this? This is larger or higher frequency compared to my transmitted signal frequency. And how much it is higher? So if I want to break this up, this is nothing but Fs plus 50 hertz. So this extra 50 hertz that is coming up in the frequency at the receiver side, this is actually called the Doppler shift or the Doppler spreading, and it is indicated by the term F of M. Okay. So here when the receiver is moving towards the transmitter with a velocity of fixed velocity of V, we see that the signal which is received at the receiver side is having higher frequency. That means the frequency of the received signal is greater than the frequency of the transmitted signal from the transmitting antenna. Now this extra shift, additional shift in the higher side, we are having addition here. This extra shift is called the Doppler shift or the Doppler spreading, or it is also called frequency shifting or frequency distortion. This is called the Doppler effect here. Okay, so this is case 1, scenario 1. Another scenario is when the receiver is moving away from the transmitter. Suppose the receiver is moving towards the transmitter, crosses this transmitter and is moving away now. Okay, so now in this case, the receiver is moving away from the transmitter. So this is my scenario 2. In this case, we experience that the frequency that is received at the receiver side, if I take this as FR2, this frequency is lower compared to the frequency of the transmitted signal. Lower means what? Suppose I am receiving here 50 hertz. Okay, so 50 is less than 100, so this is lower frequency. Now lower by how much? If you say, we can write this as the transmitted frequency minus 50 hertz, which is nothing but, again, if I notify this in terms of your Doppler spreading or Doppler shift, this is Fs minus F of M. So what is this Fm here? Fm is again the Doppler shift or the Doppler spreading or the Doppler effect here. So here we experience that the frequency is reducing and here we are experiencing frequency is increasing. So what is the difference between the two scenarios? In case 1, the receiver was moving towards the transmitter. In case 2, the receiver is moving away from the transmitter. When it is moving towards the transmitter, frequency at the receiver side is increasing. So there is spreading of the signal at the receiver side in terms of frequency. We receive higher frequency component compared to the transmitted signal. When it is moving away from the transmitter, the frequency of the received signal reduces, and we see that we are receiving lower frequency components compared to the transmitted signal. Now this plus minus FM, so I am transmitting the constant signal as Fs, but based on the position or the location of my receiver, what is changing? The received signal frequency is changing. Clear? So received signal frequency can go high or it can go low. So this plus minus FM that is there, this factor is called your Doppler shift or Doppler spreading or frequency distortion. Clear? So as your receiver or transmitter, any one of them is moving with respect to time with a fixed velocity v, what is happening? The frequency of the received signal is changing. Now when the frequency is constantly changing with respect to time, because if I say that the receiver is moving, it is a car, so it is always changing its position with respect to your transmitter. Okay. So when it is always changing its position with respect to the transmitter, what is happening? There is constant change in the frequency of the received signal. That means always the received signal frequency is fluctuating. It can go high or it can go low compared to the transmitted signal. So when this is constantly changing, what is happening? There is change in the multipath effect, and because the frequency is constantly changing, you will experience frequency dependent fading. That means constantly frequency changing, there would be fluctuation with respect to frequency in the received signal. Now this can also happen due to changes in the environmental conditions. So any change in the environment surrounding the transmitter or the receiver, that means any change in this wireless communication medium, that can also cause fluctuation in the frequency of the received signal. So what is happening here? Due to this fluctuation, the channel characteristics are constantly changing with respect to time. Okay. So frequency is constantly varying. So channel is also changing with respect to time. Why? Because there is a motion involved. Clear? So because channel is changing, now there is one big challenge at the equalizer side. What is the challenge? The challenge is the equalizer now has to predict what is the condition of the channel at every time instant. So the equalizer has to balance the effect of the channel changing constantly with time. So what it has to do? It has to constantly change its weighting coefficient. That means the multiplication factor. What is the multiplication factor? Omega k. So it is always trying to modify this multiplication factor. It cannot take it as one fixed value. It has to continuously keep on changing the value of this coefficient with respect to the change in the channel. So every time it has to detect what is the channel characteristics, and every time it has to understand what is the value of the channel characteristics and how it has to update the coefficient. According to that, it will adapt itself and it will start calculating the error factor. Now, what is the error factor here? Sorry. So, what is the error factor here? The error factor here is nothing but, just a second, is nothing but Ek is equals to dk minus dk bar. So the error is nothing but Ek. So error factor is nothing but E is equals to, or Ek is equals to DK is the transmitted symbol for digital communication, actual transmitted signal. So this is transmitter minus the regenerated signal at the receiver, that means the equalizer output. So your equalizer will always try to optimize this constant multiplication factor, and it will try to minimize this error as much as possible. So minimize this error so that the constant changing nature of the time varying nature of the channel can be overcome. That means constantly the amount of ISI is changing with time. So with changing nature of ISI, this error needs to be always be kept as minimum. So for this, we cannot use a constant multiplication factor. The multiplication factor always have to be changing with respect to time. Okay. So that is your first condition for adaptive filters or adaptive equalizers. Okay. So what is the basic operation of adaptive equalizers? So if I just go through this one by one, I've already explained this, but we will just go through one by one. So an adaptive equalizer will always keep on changing or updating its filter coefficients or multiplication factor. Why? Because the error between the actual output, means the desired output, means the transmitted signal that is done, with the received signal. So the difference between the transmitted signal and the received signal that is received, this difference is called your error factor here. So we have to constantly update the filter coefficients or weighting coefficients so that this error can be minimized and kept low as much as possible. So in this case, we will choose the weight so that the error can be minimized. And every time, what are we doing? We are updating this weight. And what is the formula that is used? The formula is this formula. So what is this formula? Here, always the new weights or multiplication factor is equals to the old weight. That means the previous weighting coefficient plus the correction term. Now in this case, only changing factor is your correction term. So as the channel is changing, this factor will change. So if I say that the channel characteristics is changing with respect to time, that means this correction term will also change corresponding to this changing nature of the channel. So every time you will track, you will first see what is the change in the channel characteristics, update the correction term. So when correction term is updated, then you are always calculating a new multiplication factor. Okay. Now, adaptive equalizers have two modes of operation. One is called training mode and the other is called the tracking mode. Training means it's like AI training only, any model training. That means once you devise one equalizer or design one adaptive equalizer, first you will use some sample data. So you will use some sample data to train the algorithm at the receiver side. So to train this adaptive equalizer model, we will use some sample data. What is sample data? Sample data means known amount of data. That means already the receiver knows what is the actual transmitted data. Using this sample data, the equalizer will be trained for the changing nature of the channel. So now equalizer will understand the nature of the channel using the training data or sample data. Once the training is completed, equalizer now knows how the channel is behaving with respect to time. Then it will start with the actual model, which is called the tracking mode. In tracking mode, the transmitter will send the actual data. Okay. So in tracking mode, we are sending the actual data instead of the sample data. So that is the difference. So there are two modes of operation in adaptive equalizer. So this is the difference of adaptive equalizer with normal linear equalizers. Normal linear equalizer means zero forcing equalizer and minimum mean square error equalizer. So in both the cases, what are we doing? In both the cases, we see that they have a constant weighting factor. In those two cases, we are not using this formula. For adaptive equalizers only, we are using this formula where the correction term is always updated with respect to the change in the channel characteristics. So as the channel is changing, the correction term is changing, and the correction term will keep on updating, and we are actually using new multiplication factor. And this entire process is conducted using two types of mode. One is called the training mode and the other is called the tracking mode. Okay. Training mode, we are using sample data, and tracking mode, we are using the actual data that is being transmitted in the communication mechanism. So what is the training mode of adaptive equalizers? Clear? So in adaptive equalizers, the training mode is used for training the equalizer to understand the nature of the channel characteristics, changing channel or time varying behavior of the channel. So transmitter is sending one training sequence. What is this training sequence? This training sequence is the sample data. Now sample means it is not the actual data. This is just used for training the equalizer, for making the equalizer understand the behavior of the channel. So sample data means, suppose I am sending 1011. So this is my sample data. That means this is my test data. Okay. So the transmitter is sending this digital symbol 11011. So this is a train of pulses. Train of pulses means 1 means there is a pulse. So again there is a pulse. 0 means there is no pulse. And 1 means there is a pulse, and again a 1 means there is a pulse. So this is 11011. So like this you are sending one transmitted signal. Okay. And the receiver already knows what is the actual signal that is being transmitted. So receiver also knows that my transmitter is sending this test data. So this is known to the receiver. Okay. That means receiver knows what is my actual data. So this is my transmitted data, which is called DK. So this is my transmitted actual data, which is sent by the transmitter. Receiver already knows that this is my actual transmitted signal. Clear? So what will be the equalizer output? The equalizer output would be that whatever is received at the equalizer output, it will multiply with the weighting coefficient and it will try to calculate the error. So the error is the actual signal minus the equalizer output. It is generating this error factor. Now with this error factors, it is calculating the time varying coefficients WK, and this time varying coefficients will be used to counterbalance the time varying nature of the channel when actual communication is being done. Okay. So in tracking mode of adaptive equalizer, transmitter is actually going to send the real signal. So suppose that real signal that is being sent is 10011. Suppose. So now the receiver does not know what is the actual signal that is being transmitted. So this is your actual data. So receiver will no longer know what is the actual data being transmitted. So what is happening? It is passing through the channel and the receiver is receiving this signal. So in receiver signal, you can have this as 11010. Like this, receiver is receiving the actual signal. So you can see here that there is distortion or there is error here. Where is the error? The error is in the second pulse and the error is in the last pulse. So this too is the error places where the receiver is not receiving the correct data. Why it is not receiving the correct data? It is not receiving the correct data because of inter-symbol interference. That means the multipath effect of the channel. Now the channel is constantly changing with respect to time. So we have already calculated this changing nature of multiplication factor based on the channel varying capacity, channel varying nature using the training mode. So from this training mode, this factor will be used to overcome this ISI. How? It will calculate the error factor and it will keep on changing the value of WK until the actual data symbol is being generated and the error is minimized. Okay. So the equalizer will track the changing channel and it will keep on updating the value of this weighting factor. So based on the previous decision, the reference values will be taken. Previous decision means based on the training data. So based on the training data, the nature of the channel will be predicted and the value of the weighting coefficient will be decided, and based on that the decision operation will be done whether the ISI is overcome or not. That means that we have to minimize this error, and as error is minimized, then we are able to overcome the effect of ISI and we will be able to regenerate this exact transmitted signal at the receiver side.